so all I did was I brought over that one graph that we had in the middle, so you should already have this graph in your notes. This is the one showing our consumption, again, as effectively a measure of income and spending. And we'll start to get more formal with this, especially this variable down here. Right now we haven't been very formal with it. What I want to do first, though, is I want to kind of come up with an equation for this, right? This is a line. I need an equation for a line. So I'm going to use effectively a slope-intercept form because I have a mathematical interpretation for slope and I have a mathematical interpretation for the intercept. So I want to be able to kind of combine these together. So if I do that, I would show that consumption is equal to A plus, so my intercept plus, MPC times DI. And don't forget that DI has its own formula, right? So that could be rewritten out as a formula in itself. But I now have a equation for the slope of my function. This gets us towards that kind of, again, this is an aggregate expenditure model. This is one component of expenditure. If you remember, Keynes also said, hey, we got to start accounting for these other components as well, right? Government, we've got to start investment, firms, we've got to start including foreigners. So remember, we came up with this equation a while ago of y equals c plus I plus g plus nx based on that Keynesian logic. All we're going to do now is we're going to take this equation and plug it in right here. So that now we're going to represent it as y is equal to A plus MPC DI plus I plus G plus NX. This component of our equation right here, this right side of the equal sign, is aggregate expenditure. This is not anything new from earlier on. In fact, if you remember some of the talk earlier on, in fact, actually, I think there was even a practice question earlier on. What is this equation saying? It still is saying income equals spending, right? It's still using that same base precept. We can then also now say, all right, I want to include these variables into to this model. So that's what I want to do. I'm going to maybe do this one a little bit bigger because I'm going to add a lot more. And really, we're just going to end up with a base ending graph anyway. So this one might be one you can just watch, or you can add to your notes if you like, whichever. So that marker died. Let's try this one. And again, I'm going to kind of call this spending. But now, because I want to be able to show all of my aggregate expenditure, I want to show all of this, I'm going to call my income axes down here, I'm going to call it Y. Because when we do combine all of our spending together, we effectively should get real GDP. So I'm going to call this Y. And then I'm going to start out with some base autonomous consumption and some consumption function. That really does not look very straight. Maybe that's a little better. And all I want to do is I want to start adding in these other variables. So let's think about the story here. Let's think about firms. What would we expect firms to behave like? Firms, so we're talking investment. Well, I would think that firms are going to respond to increases in income the same way as consumers are. As firm income rises, they're more likely to want to expand, which means more investment spending. So I totally expect firms to have also a direct relationship, also a relatively upward sloping function. I also kind of expect firms to probably have one that's going to be a little bit steeper than consumers, because we said earlier that firms have very little incentive to save. While that is probably true, if we go on the kind of the MPC argument that, hey, a lot of people think that if we include all spending in the country, it's pretty steep for the United States, right? A kind of an upper 0.9 realm. That would kind of put firms really about on the same pace as consumer spending. So while not perfectly the same slope, it's probably close. For simplicity, let's just go ahead and assume it's probably a pretty close or pretty similar slope. And if that's the case, I could say, well, all I would do is add whatever spending that firms do at any point and just say, well, there's an extra amount of spending and extra amount of spending and so on and so forth. Would firms engage in autonomous spending? Yeah, I think so. I definitely think that especially whenever a business is starting out, their income is effectively nothing, but they have to engage in a lot of capital expenditures, again, probably primarily based on the interest rate. So I think that we could even add some measure of spending even when income is zero. And if I do that, I would get a line that, while again, probably not perfectly parallel, is probably pretty close. So I'm just going to, for simplicity, assume it to be parallel. And I get a line that is C plus I, so that the difference in any point from the C to the C plus I line is the amount of investment. That's what C plus I would represent. And then I could start saying, all right, well, let's think about the government. So does the government engage in spending? Yes. Do they engage in spending even if their income is zero? Well, yeah, our government is going to spend regardless. So we know there's some autonomous measure. So I'm going to add something right away. What about the government's MPC? Well, for the United States, our government MPC is pretty darn high. Again, if you use that same idea that the government effectively spends more than their income because of their debt, it's significantly high. If you use the idea that, well, the government spends part of their income on paying off interest and not engaging in actual government consumption, maybe it gets it a little bit closer to that one measure. Brings it a little down in that case. But again, it doesn't seem like, so while again, I don't think the slope would be the same, I also don't think consumers would have a 45-degree slope. It would be much steeper. I think that in reality, the government slope has got to be fairly close to consumer slope. Again, if we think for society, we're somewhere around 0.8 or higher, and the government is probably higher, we're going to have, again, a very similar slope. So I want to do the same thing. For simplicity, I want to just say, hey, at any given point, I'm going to add some measure of government spending. So that if I had a line that represented C plus I and now plus G, the distance between any point of the orange line and the green line is the value of G, and the distance at any point between the black line and the green line is G plus I. So again, that distance would be G plus I vertically. And then finally, we have net exports. And net exports is the easiest one to add on here because we said foreign consumers behave the exact same as domestic consumers. There's going to be autonomous consumption. Foreign consumers can spend based on their wealth, based on expectations, etc. We also find that most trade countries tend to have very similar MPCs. We talked about like how it might be a little bit lower for industrialized countries. Well, who does the U.S. trade with a lot? Mexico has almost an identical MPC. Britain, yeah, pretty close. China, pretty close, yeah. In fact, actually, most of our trade partners, one of the reasons we trade with them is because economically we're pretty close to each other in a lot of regards. So I kind of expect almost the same slope as consumption here. So I would have some measure of autonomous consumption. And then at any single point, I would have some addition to spending that is brought about by foreign consumers. missed that last point, but that's okay. And then I would have a function that represents now c plus I plus g plus nx, where at any point the distance between the red and the green line is the addition of net exports. I am assuming positive, by the way. It could be negative, so it could be below the green line, absolutely possible. And the distance between the black line and the red line represents I plus G plus NX. So that vertical distance is those other expenditures in the economy. It's this red line, this final red line, that we're going to focus on. This is our aggregate expenditure line. So this is our AE function. It looks exactly the same as our consumption function, right? And again, I am being simplistic, assuming a 45-degree angle. I just like it pretty hard. Okay, so effectively, we have now checked off half of our really important macroequilibrium equation. We need to think about this other half here real quick. We need to think about this y. And we have conceded that y is equal to c plus I plus g plus nx, right? Right? We've said that is true. Y is equal to, in this case, aggregate expenditure. So now we want to say mathematically, when is that true? Again, we've already gone through the semester numerous times showing that that is true. We want to know when is that true. Okay, so like for example, let's see, we'll just make a chart. Y, AE. So if the aggregate expenditure in the economy, the component spending of GDP is $1, really small economy. What is the value for real GDP? Well, it's $1. Effectively, every dollar of spending is someone's dollar of income, right? If I pay for a product that was produced, GDP, here's $1. I have spent $1, aggregate expenditure is 1. The value of your production, what you've taken in as income, is 1. Y equals AE. It could also be true, by the way, if spending was 100 and Y was 100, and spending was 1,000 and Y was 1,000, and so on and so forth. And other than right now looking at me, rolling your eyes saying, duh, this is dumb, what you didn't realize is we've actually just created ordered pair coordinates between AE, right, spending, and Y, income. We said at these ordered pair coordinates, our math equation, from earlier in the semester to now, must be true. Those are plottable coordinates. So I could come over here and I could say, all right, well, let's plot income and spending using this information. Okay, this is probably not going to be scaled great, sorry. 1, 1. 100, 100. 1,000. 1,000, right? And I could put a point to represent all of these spots. And what do I end up with? I end up again with this nice, pretty, coming out of the origin function that exactly divides my graph in half, representing the possible scenarios, the possible values where Y could equal AE. That's what this line is showing. All the possible values where Y could equal AE. It makes a nice, pretty 45-degree angle function. We are super uncreative in economics. we called this line the 45-degree production line. So the 45-degree production line. So these are all the possible coordinates where y could equal AE. We want to know, where does y equal AE? In order to do that, I need to take this graph, same axes, pick it up, and overlay it onto here. Now, I am only going to use the AE function. And when I pick it up and lay it on, I have an aggregate expenditure function that has some autonomous value, some MPC slope, right? This would be, A. I would have some slope in there. And I have a function for aggregate expenditure. And you'll notice that these two functions intersect. At this one exact point, y equals AE. This is our real GDP for the economy in the model.